Welcome to a course on Calculus for Business. Yes, we are about to start a new course on Calculus for Business, which is a part of business mathematics. Okay, before technically getting into the concepts of this, let us have a discussion kind of a thing to see where this calculus arises in nature or where this calculus arises in business. Okay, let us start with the case where a man makes twice the money of what he invests. This is the scenario. This we will have to convert into mathematical terms. If suppose something is given like this, what do? Actually, he makes twice of that, right? So let us take y as the money he makes and x as the money he invests. So when we have something of this sort, how do we write it? Here we know this y is 2x. So whatever he invests is going to get the double of these things. Okay, here we have this y and x, these things, right? What is this y and x are? Okay, here there are three things involved: x, y and this 2. Okay, out of these things, this x and y, these are called as variables because these can take any value, right? Whatever may be these can take any value in the sense on the possibilities, right? He can invest 10 rupees, 100 rupees, 1000 rupees, a lakh, a crore, a billion. Okay, it is up to him to invest whatever he wants, but whatever he invests, he is going to get the double out of it. Okay, so that thing, let me hold that for a while and come back to this. It is given that he is making twice, so we have written 2 here. If it is given he is making thrice, means we will have 3 here. So this 2 is not going to be changed at any cost. So these kind of things, values are called as constants, right? So why we are discussing about variables and constants here in this sense? In calculus we will deal with variables and constants. Okay, here now coming back to the variables over here, based on his investment only he is going to get his income, right? So this investment, this y value depends here. This y depends on x. Hence, this x is called as independent variable because it does not depend on anything. Okay, his wish, he can invest whatever he wants. Okay, but based on his investment only he is going to earn. So this y here is dependent variable. Okay, so we have these things. What has it to do with calculus? Yes, of course, this is where a calculus begins. Let us see where it begins. Okay, suppose let us consider the case when x is 1. Okay, he is investing 1 lakh, let us say. Okay, when he is investing 1 lakh, he is going to get what? 2 lakhs. When he increased his investment to 2 lakhs, then he would get what? That is 2 times of 2, that is going to be 4. Okay, what is the ratio in his, what is the ratio that has changed in his income? That will be y of 2 minus y of 1 divided by 2 minus 1, which is going to be 4 minus 2 upon 1, which is 2. Suppose he, from this 1, he has increased 2 units, which means he is investing 3 lakh. In that case, y of 3 is going to be 2 times of 3, which is 6, and hence this ratio will be 3 minus 1, which is 6 minus 2 upon 2, and what? This is simply 4 minus 2 upon 2, sorry, 6 minus 2 is 4, 4 upon 2 is going to be 2. Okay, now let us come this way. Initially he is investing 2 lakhs, then he has increased it to 3 lakhs, then we would get y of 3 minus y of 2 upon 3 minus 2, which is going to be 6 minus 4 upon 1, which is 2. Okay, in everywhere we are getting this 2, which means whatever maybe the change happens, the cumulative change is 2 units, right? Exactly, this is the calculus is. Okay, physically what do we mean by a change? Okay, we have something called about a change. Here we have discussed mathematically the change. The change we call it as derivative mathematically. Okay, change in natural terms leads to the concept of derivative in mathematics. Precisely speaking, that is the rate of change. Okay, here rate of change is the one that we call it as derivative. Okay, here I have taken 2 units, 2 lakh, 1 lakh, these kind of things. Sometimes this may be spoken like 1.5, even for 1.5 we may talk, right? If we go with that, what would we get? Y of 2 minus y of 1.5 upon like 2 minus 1.5, and this would be 4 minus 3 upon 0.5. Even in this case, we are going to get 1 upon 0.5, which turns to be 2. The rate of change we speak for very minute terms. Okay, mathematically defining the derivative, that rate of change. Let me give you the definition now. Okay, before getting into the mathematical definition, let us see the normal definition. Rate of change, change in the function behavior upon change in the independent variable. Here, what is the function? This y. Actually, initially what we had, y is 2x, right? So this may also be written as f of x, some function of x. Based on the value of x, we are going to get the value of y, and that is why this is called as function of x, right? So that is the change in the function behavior when there is a change in the independent variable, right? This rate of change we call, this is the rate of change. Okay, when there is a very minute change in the independent variable. Suppose if x is my independent variable, the minute change I represent as delta x. Okay, a minute, a very small change. Okay, so what am I going to do is that this is what I will have in the denominator. Mathematically speaking, this is what I am going to have in the denominator. Okay, then the corresponding function values has to be in the numerator. Okay, we said a very small change. A very small change can mathematically set as delta x approaches 0. This approaches 0 means it is not exactly equal to 0, it is going very near to 0. Okay, that very near to 0 depends on what case we are dealing with. If I am running a small industry, like a very small industry where each paisa, okay, if I have to get 11 rupees 50 paise from a person, even that 50 paise matters to me. In that case, my small change would be what? 1 paise. Okay, even that 1 paise is a big to me, in the sense I have to consider that 1 paise as a big quantity, which means I'll have to consider like a 0.001. If this is the case, I can take this to be small, whereas I cannot take this to be a small quantity. That 10 paise matters to me. Whereas if I am running a MNC, I don't care about this paise and all. If I have to give someone 9,999, I would give them 10,000. I don't care. That 1 rupee doesn't matter to me much. So this approaches 0 depends on cases based on the functions, right? So simply we cannot generalize these things naturally. That is why we have the concept of this limits, that approaching concept in mathematics that fits into the situations as it wants, right? So as delta approaches, as this delta x approaches 0, what is going to happen in this rate of change is called as the derivative of a function. Okay, we represent that as df upon dx. Here this df upon dx, this is the, actually this is what we write like this. This means what is the change happening with f, the rate of change of f when there is a change in x. This is what we mean, and this may also be denoted as f prime of x, or simply known as f dash of x. And we know very well that this is this denominator x gets cancelled, so we will be left with x plus delta x minus f of x upon delta x. Okay, and this is how differentiation arose, right? While dealing about these things, I have spoken about variables, constants, these things, right? Okay, do constants really matter? Yes, of course. If you are running a printing, okay, if you are running a printing industry, if I am coming to you to get my books printed, okay, for the typesetting charges you will charge me, right? So the typesetting charges, let us say the typesetting charges is fixed, is going to be 10,000, let us say. Okay, now you are telling me that for each copy of a book you will charge me 5,000. Okay, for a copy it is 5,000. Okay, now you are asking me how many copies do you need. You have said these details to me, that is the typesetting charges is going to be 10,000, and for a copy it is going to be 5,000. Okay, 5,000 seems quite large amount, so let us have this as 500. Okay, for a copy you are going to charge me 500, and you are asking me how many copies do you need. If I tell you the number of copies, so that you can make a invoice or a bill copy to me, so that I can pay the money, right? If this is the case, how is it going to be? I am saying I need 50 copies. Then what would you do? This 10,000 plus 500 into 50. This is what you will calculate and tell me what should I pay, right? If I say 75 copies, then it is going to be 10,000 times of 500, 10,000 plus 500 times of 75. Okay, I said okay, I need 75 copies. You have calculated these things and you are telling me this is the amount that I should pay. Suddenly I got a call from my co-author. He said, I think 75 copies will not be enough. We need more number of copies. You just tell them that we need minimum of 100 copies, and if that is a need, we'll let them know and they have to give us the copies. My co-author is asking me to convey this to the printing shop. In that case, what is going to be happen? I am conveying these messages to them, and I want something to happen. I should know what should I pay. In this case, this thing may be generalized as 10,000 plus 500 times of the number of copies. Let us take n to be the number of copies. Right? So, depends on the situation and depends on the requirements, the number of copies is varied. It may vary. So here this number of copies is a variable. Whereas this one, you just look at this one. Even this 500 is a constant here. But why am I asking you to consider this 10,000 as this is a constant? And this is what? This is a fixed cost. The cost of typesetting, it is a fixed one. Whereas this 500 is a variable cost. Based on the copies, you are going to charge me, right? So this is a variable cost. So like this, we may frame any function in a mathematical way that occurs in business, right? Whenever we wish to study about the change happening in that function, we comes to the concept of differentiation and the derivative. Okay, so I said this is the notation for derivative, and this is called as derivative of f. We have seen what do we mean by derivative and where does this occur. Okay, suppose let us consider the case, whatever I invest, I am going to actually when it gets doubled, we had 2x. Okay, suppose if I invest x rupees, I am going to get x times of x. Suppose this is the case, then one income will be what? Y is x square. What is the rate of change happening here? Okay, initially when it is doubled, we get this dy upon ds as 2. Okay, so this one we got from the example. We have not calculated it mathematically, we just calculated it from the ideology behind it. Okay, suppose we have this. Okay, then that is what we have is y of x is x square. Then what is going to happen with y of x plus delta x? So this will be x plus delta x times of x plus delta x whole square. And we all know from the schoolings itself that a plus b whole square is a square plus b square plus 2ab. And some of us may even remember only that from our school days. So we shall apply it. So it is going to be x square plus delta x square plus 2 times of x delta x. Right? Now let us calculate limit delta x approaches 0, y of x plus delta x minus y of x divided by x plus delta x minus x. So this will be what? Limit delta x approaches 0, and this is going to be x square plus delta x whole square plus 2x delta x minus x square. So this is our y of x plus delta x value, and this is going to be our x square value upon, in the denominator x and x gets cancelled, we have delta x, right? Now this x square and this x square gets cancelled, and we are left with the possibility that limit delta x approaches 0, delta x whole square plus 2x delta x upon x. Okay, since this is approaching 0, we may take this is with is very smaller quantity, and we shall try to substitute delta x as 0 on the numerator as well as on the denominator. If we do so, we are going to get 0 by 0. We don't know what is that. Okay, we have some results like anything upon 0 is undefined, 0 upon anything is 0, provided something we have is non-zero, something we have is non-zero, right? While studying these things, anything divided by 0 is infinity, and 0 divided by anything is 0. These things we have studied in school. Yes, of course, I agree to it. But we fail to remember that anything has to be non-zero. Okay, so we shall not use this here. And what are we going to do? This is limit delta x approaches 0. In the numerator, we may try to take this delta x outside. So delta x plus 2x upon delta x. Now we can cancel these two things, right? Now you just make it. Since this is approaching 0, this quantity is approximately equal to 0. So when you make this as 0, you are left with what? 2x. Therefore, your dy upon dx or simply y prime is 2x, right? That is derivative of x square is 2x. Okay, when we have something of this sort, this is fine. Let us try to extend this idea. Okay, that is y is x cube, in the sense what are we going to get? So in this case we need this x plus delta x whole cube, right? So let me give you the formula if you don't remember. That is a plus b whole cube is a cube plus 3a square b plus 3ab square plus b cube. Okay, so this is going to be x cube plus 3x square delta x plus 3x delta x square plus delta x whole cube. So here this y plus y of x plus delta x minus y of x upon here this x plus delta x minus x. Let me not do it completely. So this one you may very well see that you can take delta x in the numerator, since this x cube and the x cube over here will get cancelled, and we'll have 3x square plus 3x delta x plus delta x whole square upon delta x, and these two gets cancelled and we'll be left with this. So when we take limit delta x goes to 0 of y of x plus delta x minus y of x upon delta x. So when you make delta x goes to 0, this quantity is 0 and this quantity is 0, and we'll be left with 3x square. Therefore, derivative of x cube is 3x square. Now, this may need some generalization. How are we going to do it? Okay, generalization can be obtained from the observation, or we may do it for the general case. So whatever we have x power n, here you see you have square, you have cube, but whatever you have comes to the base. So if we have n here, it is going to come to the base. Okay, and this 2, here we have 1, here we had 3 but we had 2. So this 1 shall be written as 2 minus 1, and this 2 shall be written as 3 minus 1, and this exactly happens to be the generalization. Okay, if you wish to get this generalization using the same idea, you may try it. I am not going to do it, for which let me give you the general formula: a plus b whole power n. This is going to be a power n plus nc1 a power n minus 1b plus nc2 a power n minus 2b square, and it goes till b power n, where this nc1 means it is simply n. NC2 means n into n minus 1 divided by 1 into 2. So in general, NCR would be n into n minus 1 into till it goes n minus r minus 1. 2 means 1, r means r minus 1 divided by from 1 to 2. Here we have actually 1. So it is going to be 1 into 2 into till r. So with this, you may calculate these things and you can see this happens to be the generalization. Okay, thank you.